is Dr. Marina Milner-Balodin, and I'm a science educator at the University of British Columbia at the Department of Curriculum and Pedagogy. Today, we're going to talk a little bit about one of the applications of an amazing discovery by Michael Faraday that happened in 1831, almost 200 years ago. Michael Faraday discovered that changing magnetic field, for example, if I move this magnet through the coil, can generate electric current in the coil, which you can see through the needle of this galvanometer moving in and out. So this was a very, very important discovery because it showed how you can generate electric current in a coil without this coil being connected to the battery. Now let's think how you can use this idea for something that you probably use every day when you're brushing your teeth. A lot of us, when we brush our teeth, we use motorized toothbrush. The toothbrushes, those are really nice toothbrushes that we do not need to charge. Or maybe we do. Maybe we do charge them when we put them on the base. So the base is connected to the electric outlet, and you put the toothbrush on, and if you touch the handle, you feel that the handle gets warm. But if you look carefully, how can this happen? Because the base is made out of plastic, and the inside of the toothbrush is also made out of plastic. So how can you charge the toothbrush if you don't even have any connection through a metal or a wire, metal wire? The idea here is that is an application of Michael Faraday's electromagnetic induction. What Faraday discovered can be applied in this way. Imagine that I have a coil, and this coil is connected to a power outlet. Let's imagine that it is connected to the power outlet as you have it at your home. This is called alternating current because the current in this power outlet changes all the time. So the current through this coil changes all the time. As a result, based on Ørsted's discovery that electric current generates electromagnetic field, what happens, this coil creates magnetic field. And this magnetic field is changing. And therefore, this coil is called a solenoid or an electromagnet. In other words, a magnet that is created by electric current flowing through it. And this magnetic field that is changing all the time is going to propagate through this coil. As a result, in this coil, there will be induced electric current. And this electric current is what is used in this toothbrushes to power them. Now, to prove that this is the right idea, what we need to do, you need to open this up. Let's do that, and I will use an old one because I do not want to break a new one. So I'm opening up the base of the toothbrush, and I hope you can see that next to this cadmium battery, you have a tiny coil. And this is like this one, just much, much smaller. And this is similar coil, but larger, is placed inside the base. So what happens, we have here two coils. And this coil, the coil of the base, is connected to the power outlet. So the magnetic field through this coil generates magnetic field that is changing all the time. And this magnetic field induces electric current through coil number 2. And this current is what charges the cadmium battery in it. So every day when you brush your teeth, you're brushing your teeth with a motorized toothbrush like this one, you have to think of Michael Faraday. And if you think even harder, you can also think about Ørsted. Those two people have helped us understand how electricity and magnetism are interrelated.